Hare Krishna, everyone. I hope you can see my screen. Is my screen visible?
Yes, bro, it is visible.
Okay. Some people were asking clarification in this question. Last question of assignment 2. What was the doubt here? So this is here you just have to find the product of two matrices. So two matrices are given of their size A cross B and B cross C. So you can always multiply them because B is common here, and the resultant matrix will be of order A cross C. So are you asking me the answer or some clarification in this question? How to proceed? Okay. So whenever you want to write some logic, so how do you do? So uh, so whenever you want to write some code, you just think of the procedure which you do when you solve it normally on your own. So how do you multiply two matrices? You multiply two matrices by uh, to find the first element of the matrix in the product. You multiply the first row of the first matrix and the first column of the second matrix, right? So I hope that is clear. To find the first element of the new matrix, you multiply the first row of the first matrix and first column of the second matrix. So so how do you multiply the first row and second column? So to multiply the first row and second column, you will have to iterate through the um, through all the elements in the first row of the first matrix and through all the elements in the second in the first column of the second matrix. So from there you should get the idea that you need to use two loops. Okay. And now I have to repeat this procedure for every element of the new matrix. So you will get another for loop. So what should I do? So I can write for I in range. So I am going to um, uh, like okay. So if I do it in range A, so totally I hope you understood that we need to use three loops. So two loops are required to multiply a row with a column, because I have to go through the entire row and entire column, and at each step I should multiply and add them. And I have to do this procedure for the entire new matrix. So from there you need to get the idea that we are going to use three for loops and they must be nested. So I'll explain you once I write the code. So you can or we need to keep this. So let me call that is called as M. So since we are allowed to take two parameters, that is M1 and M2, length of M1, length of M2 would make proper sense. No, 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 no. We are allowed to take the values of A, B, and C. M1 and M2 are matrices. So the user will enter the values of A, B, and C, and then he will enter the values of, that means the numbers present in M1, M2. So suppose, yes, but not in function first line of the problem. Okay. So to a function, to a function you can pass A, B, C and M1, M2 matrices itself. Length of M1, length of M2. Okay, you are storing M1 and M2 as a list or tuple and then you are passing them. So it depends on how you are writing your code. That's okay, but I'm explaining to those who have problem about the logic. So implementation part you can write as per your wish. That is of no problem. I'm explaining the logic part, or some people have problem in uh, proceeding with the logic. So I'm explaining the logic part. So this notation depends on how you are taking M1, M2. When I write Mij, so this is not my exact code. So it depends on how you are implementing M and M1, M2. So, so when I write M of ij, I'm just referring to the ijth element of M. So whatever is your logic, whatever is your code, depending on that, you can write here. So now, so uh, uh, so those who so I'm explaining the logic. So in the matrix M, for each element of the resultant matrix M, I need to do one multiplication of the row and multiplication of the column. So in the outer loop, I'm taking A and C because uh, because the size of my final matrix is A cross C. So I have to do the entire procedure A cross C times. So in the outer loop, I'm keeping A cross C in the outer two loops. I hope it is making sense. So next, so so let's say I'm finding the ijth element of M. Then I should multiply the ith row of M1 and jth column of M2, right? So ith row of M1 will be like M1 of I and all values of column. That means I need to take the entire row, right? So M1 ik into M2 kj, because I'm taking an element of the first of the ith row and I'm multiplying with the same element of the, I mean, so it is here, it is k and k. I hope it is clear why it is k and k. Because the first element of the row, I have to multiply with the first element of the column here, and second element of the row here should be multiplied with the second element of the column here. And k is running up to b. So that is correct, and all of such multiplication should be added together. So I hope this plus equal to is clear. So plus equal to means a plus equal to b means a equals a plus b. So what happens? So so take some value of ij here. So let's see what happens in this loop. So m of ij, initially we need to set it to 0 here. That is important. So initially value is 0. So when k is 0, it will be multiplying m1 of I0 into m2 of 0j, and it will be adding it to mij. So it is multiplying the first element of the row and first element of the column, and it is adding to mij. So when k becomes 1, it is adding the next element of the row. It is multiplying the next element of the row with the next element of the column and adding it to this. So that is what we do in matrix multiplication. We multiply the corresponding elements of row and column and add their products to get the, so when this loop ends, all the multiplication will be done and you will get the final value in the position mij. And this is running for A to C. So yeah, it is consistent because I have A rows and C columns in my final matrix. I hope this is clear. Why are we adding? See, in matrix multiplication, how do you multiply? So, how do you multiply a matrix? So this is an element of the first row, right? This is an element first. This is an element of the first of the row, and this is an element of the column, and you multiply them and add them, right? So how? See this 1 into 10. So I hope this screen is visible. Here I have 1 into 10 plus 2 into 20, right? This plus, I'm talking about this plus there. In each iteration of that k loop, I'm doing this multiplication, and that plus refers to this plus. Okay. I hope it is clear. So the exact code, it depends on how you are using um, M1, M2. So the rest part of the code you can write on your own. So this is the main logic. That's it. Okay. Okay. Some some people were absent yesterday for pandas class. It is important to know pandas. Pandas is a very important library in Python. So don't do this. It is important for you to uh, know pandas. So don't miss the classes. So today we were planning to finish it today, but uh, we'll keep tomorrow session as well. So today we'll be seeing one more important library of Python, that is NumPy, and then we will see some theoretical part of machine learning which does not require the knowledge of these libraries. So tomorrow we will be revising pandas and doing two more important libraries, that is Seaborn on Matplotlib. So after that we will see uh, the code of this machine learning part whose theory we have done today. Okay. So tomorrow's class is also important. So please attend. And I hope everybody has installed pandas. How many of you have installed pandas? I had sent the instructions to install Panda. Okay, so most of you have installed. So those who are facing problems, please message me or contact any of the seniors. Okay, so I will. So those who are using Anaconda, for them it will be easy. I hope I had sent the instructions for Anaconda. So open the Anaconda prompt like this. So and then so those who have installed pandas, they can do it now easily. Like uh, you can open your environment which you have created by writing conda activate, and I have named my environment as project. So I'll write project here. So this is the name of my environment. You can so you should know which environment name you had given. So this will uh, open my environment. So you can see here this bracket shows which environment it is working in. So conda activate project means it goes into the project environment here. So now so whatever environment you had used, you had installed pandas, you can install different other libraries also by going into that environment and then writing conda install whatever new libraries. Let's say NumPy, you want to install NumPy later, you can just write conda install NumPy. Then it will install NumPy as well, similar to pandas. So you can install any library in a similar manner. So after installing NumPy, so your environment will now have both pandas as well as NumPy. So you can work in the same thing. Okay, here I had already installed NumPy, so I'm just opening Jupyter Lab. So to open Jupyter Lab, you can just write Jupyter Lab, and it will open the Jupyter Lab. And you'll get a screen like this. I hope the screen is visible. So this is the Jupyter Lab. So so here by clicking on this, you can by clicking on this you can control where you want to create your file or which file you want to open. So I have opened here downloads and temp. So if you can click on this, you can see the different folders where you can um, where you want to open the Jupyter Lab or this one. Uh, so you can also create a new file folder by clicking this. You can click this as well to create a new notebook. So to create a new notebook, click this one and click this one. So Python 3 IPy kernel. So this will be it is showing a notebook. That means this is a Jupyter notebook. If you click this, it will create a new notebook in this location. If there are existing ones, you can simply click them to open. Hit here like this. How to install NumPy or Pandas in VS Code? See, in you can open this in VS Code as well by using. Have you Harsh? Have you installed Anaconda or Pip? You both. Okay, then you can just open VS Code, and in the terminal you can write that pip install NumPy. I had sent a YouTube video for pip, so you can follow the instructions for pip. Then in VS Code you'll get. In fact, using Anaconda as well, you can open VS Code. By you can go to Anaconda Navigator, and then you can create an environment. Um, so I can send you that link as well. You can create an environment by installing NumPy and Pandas, and you can launch that environment using VS Code. You can do it using the Anaconda prompt as well. I'm not sure about the uh, command exactly what in Anaconda prompt you have to do. Maybe by writing VS Code, it can open VS Code as well. I'll send you that part if you want to do it with Anaconda. But you can do it with pip by using simply pip install pandas. You can see the YouTube video which I have already posted for pip. Okay. I hope that is okay. Okay, so we are seeing NumPy today. So NumPy is also an important library in Python. It is as the name suggests, it is numerical Python. So it is somewhat mathematical library, or it's basically a linear algebra library. It is important for data science in Python. It is also one of the main building blocks to deal with for usage in machine learning as well. So NumPy is also very fast because of its bindings to C libraries. So installation instructions have already been given. So you can import any library by simply writing import using the import keyword. So here you can simply write import NumPy as NP. So as NP meaning this is optional. So import NumPy is enough to import NumPy to your program. So this as NP is we are just creating a short form for NumPy so that whenever you want to write NumPy later in your program, you can simply write NP. So this is you can write here N as well. So this is and later you can just use N instead of NumPy. It is your choice. instead of just to avoid writing numpy each and every time, we are just creating a short form here. That is a use of this as. Okay. So in most of these libraries, you just have to know the functions and functions which are important in that library. And I hope you had seen the different functions in pandas yesterday as well. So here also we have numpy arrays. So don't get confused with this arrays and the arrays using array module. So we had not discussed that array module in class. I had posted someone had asked a doubt about that arrays. I had posted about the array module on Google Classroom in a written form in some doubt clarification on some day. So that is not actually very much used. It does not have very important functionality uh, you for doing mathematical operations and other things. Moreover, that array should consist of uh, elements of the same data type. But NumPy arrays are having many much more functionalities and are more useful, more used. So this NumPy arrays come in two flavors. Meaning in two ways, vectors and matrices. That means you can use NumPy arrays as simply an array, one-dimensional array or a two-dimensional array. That is the meaning. So when I say two-dimensional, it is not exactly a two-dimensional array. It is not exactly two-dimensional. It is so it is basically an array of arrays. So when we go through that part, you will note, you will see that. So you can create a NumPy array by using a Python list. So you have a list and you can convert it into a NumPy array by writing np dot array. Array is a function which converts the list into array type. So np dot array and pass the list, it will create into a NumPy array. So this is what is np. So if you simply wrote import NumPy here, if you simply wrote import NumPy here without writing as np, you will have to write here NumPy dot array. So to avoid writing NumPy each and every time, we have used as there. So np dot array will give this. So now you can see that the matrix which we are referring to is this. So it is like a list. It is like a nested list. It is not exactly two-dimensional or something. So it is a list of lists which will behave like two-dimensional, because this will be like the first row, and then each of them is the columns. This is behaving like the second row. This is behaving like the third row. So it is an implementation of a matrix. So you can convert it to an array by passing that also into np.array. So it is again a array where each element is a list: 1, 2, 3, 4, 5, 6, and 7, 8, 9. So this array consists of 3 elements where each element is a list. And this is the implementation of matrix using NumPy array. So we have some built-in methods. So arrange is a built-in method. So np.arrange 0, 10 will give you uh, evenly spaced values between 0 and 10, where 0 is included and 10 is not included. Always be careful about this. The starting value will be included and the ending value which is specified is not included. So if you are not specifying the third argument, it will be spaced by 1. Like, so if you give 0 to 10, it will give an array of consisting of elements 0, 1, 2, 3, and so on up to 9. If you give the third element, let's say 2 here, so it will give values spaced by 2. So it will start from 0 because 0 is starting here, and 2, 4, 6, 8, 10 because here 11. So 10 can be included. So this arrange method uh, is available in NumPy, and it will return an array of evenly spaced elements. So there is also this functions of zeros and ones. So if you write np.zeros, it will give you an array consisting of 3 zeros. If you write 5, 5 as a tuple, it will give you a matrix of size 5 cross 5 where every element is 0. So it's a 0 matrix. So if you give a single number, it is a single one-dimensional array. If you give a tuple, it is a two-dimensional array, or basically it's an implementation of the matrix. So you can see if I change this order, you can see it is giving 3 elements where each element is a list of 5 zeros. So each element is a list and each list is like the row of the matrix. So this is like 3 cross 5. So 3 rows meaning 3 elements, 3 lists, where each list has 5 columns or 5 elements. So similarly, we have ones where it will give an array of all ones or a matrix of all ones. And we have the linspace method. So this linspace method also will give you the evenly spaced numbers, but now you won't specify the difference. So here you can see that you are specifying the difference in arrange. So this 2 refer to the difference between two consecutive elements in the array. But in linspace, you will specify the number of elements you want in the array. So you are saying that I want 3 elements which are equally spaced between 0 and 10. And so it gives this. Here 10 is included. I hope you see the difference. So there are two differences. The second, the end point is included. The last end point is included, and this is not the space. This is the number of elements which you want. So if you want 50 elements between 0 and 1, you can specify 0, 10, 50. So 0 to 10, 50 numbers will be given as an array. I hope you see the difference between linspace and arrange. So similarly, you have the I function, which this I function will give you the identity matrix. So np.i4 will give you an identity matrix of size 4 cross 4. So you can observe that there is only one argument, but it is giving a matrix. So this I itself means an identity matrix, and identity matrix is always a square matrix. So only one argument is required. So 4 means 4 cross 4. So you have this random function. Random function is called as rand. So you write it as np.random.rand. So this rand function will give you uh, give you a number between 0 and 1. And if you give the parameter here 2, it means it gives two random numbers between 0 and 1 as an array. If you specify at 5 comma 5, it gives uh, uh, a matrix of size 5 cross 5 where each element is a number between 0 and 1. So here you can see that it gives random samples from a uniform distribution over 0, 1. So what is a uniform distribution over 0, 1? That means every number between 0 and 1, where 1 is excluded, 0 is included, is equally likely to occur. That means the probability that any element will be returned by the random function is the same. That means every element between 0, 1 is equally likely to occur. That is uniform distribution. But if you use the rand n function, the rand n function will give you will give you samples from a standard normal distribution. Standard normal distribution is basically the Gaussian distribution. I hope everybody knows the Gaussian distribution. This is a Gaussian distribution. So this kind of a graph will be there for Gaussian distribution, and this function will. So this is the mean, and this will be the standard deviation. Up to some point here. This will be the standard deviation. So this random function will use a normal distribution or a Gaussian distribution with mean as 0 and standard deviation as 1. So so what is the meaning of this graph? Uh, the values near to 0 will be more likely to occur. That means if you call the random function 10 times, most of the values might come very close to 0. So that is the meaning of standard normal distribution. But in the previous case, it was uniform distribution. So any value was equally likely to occur. And that was between 0, 1. Here it is between -1 and 1. It is not exactly between -1 and 1. It can be more than 1 and -1 as well. But the standard deviation is 1. So most of the values will occur between -1 and 1. Other values can also occur. So you can see there are some values like 2.2 also. So other values can also occur, but because the standard deviation is 1, so most of the values will be between -1 and 1 because that probability is high. So that is a randn function and the rand function. So rand int will give you a random integer between the specified values. So if you specify np.random.randint from 1 comma 100, so it gives a number, a random integer between 1 and 100, where 1 is included and 100 is not included. That means it can possibly give 1, but it will never give you 100. It will give any number between 1 and 99, um, meaning any integer between 1 and 99. So so if you pass another parameter, that is, let's say 10, that means it gives 10 random integers between 1 and 100. If you don't pass anything, it gives only 1. So we have seen the arrange function and random.random function. Now uh, we we are just uh, recapping it. We are telling you that this arrange will return an array, which we have already seen. So you can see here, array is giving an array, uh, meaning the type of this is an array object, NumPy array object, and even this randint is giving an array, a NumPy array object. So this is giving you 10 values between 0 and 50, and this is giving you equally spaced values, 25 values. So if we have not mentioned even the starting value, so it starts from 0 only. So you can see here arrange, we had done 0 comma 10, that means it starts from 0 to 9. We did not specify the difference, so it will take the difference as automatically 1. If you specify the difference, it takes that difference. And if you don't specify even the starting value, if you give only one number as input, then it will start from 0. As you can see here, np arrange 25 gives 0 to 24. What happens if you give a negative number? Let's try. So it is giving an empty array. You can see that. Okay, so there is another one function called as reshape. So this reshape is basically reshapes the array into the required size. So we had this array ARR. ARR was basically this array whose size is 25 cross 1. Sorry, 1 cross 25. So this array has size 1 cross 25. I want to reshape it into a 5 cross 5 matrix. So I can write array dot reshape 5 cross 5. So it will reshape into this matrix implementation. So you can see that the first 5 elements will become the first row. That means the first list. Then the next 5 elements will become the second row or the second list, and so on. So other functions are basically maximum, minimum, argmin, etc. So we had this array we had created previously, random array, and this dot max will give you the maximum element in that array, and argmax will give you the location of uh, that, or basically the index of that in the array, like 0 1 2 3 4 5. So 49 is at index 5, so that is giving the index. So min will give you the minimum element, and argmin will give you the location of the minimum element or index of the minimum element in the array. So these are all simple functions. So again, array.shape will return the shape of the array. That means the size of the array. So array.shape here it is giving 25 comma this, meaning it is a one-dimensional array of size 25, or basically you can think of it as an array of size 25 cross 1. So if you reshape it into 1 cross 25, So this is 25 cross 1, this is 1 cross 25. Now you see the shape of it. Now you see the shape of it. It is 1 cross 25. That means it consists of only one row. I'm sorry. I think uh, I told the reverse previously. So this uh, when you create an array of one dimensional array, it is basically uh, one column and not one row. So whenever you're doing this array 1 2 3 one dimensional array, so this is like one column. So what is the size of this array? The size of this array is uh, 3 cross 1. 3 cross 1. So there are 3 rows and 1 column only. So this is 3 cross 1. So that will be reported as 3 comma. So just like here, it was a single dimensional array of 25 elements. So the size was 25 cross 1. So there are 25 rows and 1 column. So you can reshape it into 1 cross 25. So, so when you reshape it into 1 cross 25, you get a matrix of 1 row and 25 columns. So one row meaning one list of 25 columns. So you can see this is present is a so this array has one element which is a list of 25 elements. So now if you take the shape, it is 1 comma 25. So be careful. A single dimensional array is like a column, and in a matrix each list is a row. I hope it is clear. If you reshape it into 25 cross 1, it will be this. So this 20 so you observe the difference. So so initially it was uh, a single dimensional array, and when you asked its shape, it is 25. But when you purposefully mention 25 cross 1, so it will give a matrix implementation and not a single dimensional array. So it is giving a 25 cross 1 matrix. So now there are 25 rows. So so it will give 25 lists as elements. So so a matrix with one column, so a matrix implementation with one column is different from a single dimensional array. So this 25 comma 1 is not same as this 25 comma this. So this is single dimensional array of 25 elements which behaves like one column, but this is a actual matrix of one column. So now if you ask its shape, it will show you 25 comma 1 properly. And you can see the data type of the object in the array. That means array.data type. So it will give you the data type. So int 32 meaning integer type, and 32 indicates the size of each element. That is 32 by 32 bits or 4 bytes. We have to move faster. Okay. So we have uh, seen this arrange function. So this is basically the starting point of this for the next part. So we are just creating an array to use it later. So using the arrange function, and we'll see the indexing and selection part. So again, just like a list, you can access the array elements by using the index, where index starts from 0 again. And you can get the subarray by using this uh, 1:5 kind of notation, where 1 is included and 5 is not included, where 1 and 5 refer to indexes. That means they are starting from 0. So this 1 refers to the second element. Okay. And 0:5 will be 0, excluding 5. Okay. So indexing and selection is similar to list. So broadcasting means uh, so this is where extra functionalities of NumPy arrays come up, which are not present in the Python lists. Like normal lists cannot do this, but NumPy arrays have this different capabilities. So you can write array 0:5 equal to 100. That means all the elements from with index 0 to 4 will be put as 100. So you can see the output will be this. So all these elements will be made 100. You cannot do this directly in Python list. So uh, so we are just resetting it into the original part so that we can use it later. And you can this is the slice of the array. We know this notation. And when you write this kind of a notation, so you have put the slice of the array into a new variable slice of r, and you are writing slice of r with square brackets a colon equal to 99. That means all the elements of this array should be put to 99. That is the meaning of this. So here if you mention some range and put it equal to 100, that part will be put as 100. If you don't mention anything, then all elements will be put into 100. So it is that. Okay. So now one important thing to notice. So we had created a slice uh, of the array by using this 0 is to 6, and we put all the elements of this slice equal to 99. But now you see the original array. So the original array has also changed to 99. The first six elements have changed to 99. So you can see that NumPy arrays are not copied um, when you slice it. So slicing just creates another new pointer to that, but the memory remains same. So if you make changes in this slice of array, it will change the elements in the array as well. So slices do not create new arrays. Uh, it just uses the same memory. So data is not copied. It is just the original array itself, which is treated using the new pointer. So this is a new pointer slice of array. It points to the same memory, but uh, but it is referring to the first six variables, first six elements. So these are the some uh, uses or different capabilities that you can do with uh, NumPy arrays. If you want to get a copy, that means you want to really get you want to really get another array, such that if you make uh, changes in this, it should not reflect in the array, in the original array. So you can write array.copy. So this will copy it into a new memory. So into a new memory, the same elements will be put, and this new variable will refer to that memory. So if you make changes in that memory, it won't reflect in this. So again, uh, this we are coming back to this matrices. So the matrices were implemented using the nested kind of annotation arrays where each element is a list. So so again we are as we saw that we can convert a list into an array. Similarly, you can convert a tuple of lists. So you can see that this is a tuple of lists. Tuple of lists can also be converted to an two-dimensional array by using the array function. We had seen this. We had seen the list into one-dimensional array by in the first slide. No, we have not covered pandas before NumPy today. We had covered pandas yesterday. We will revise it tomorrow. Okay, so this is one another important functionality of NumPy arrays. So you can access the entire first row by simply writing array 2d of 1. So array 2d of 1 is will give you the first row. So here you can see it is not exactly an implementation of it is not exactly how you think of matrices. So array 2d of 1 is giving you the second element of the array, which is this list. That means index 1. So it is giving you the second row itself. So but if you think in terms of matrices, you won't be thinking it in this way, right? So it is like a nested list. So that is why it is working in this way. So it is an implementation of a matrix using the nested notation. So array 2d of 1 0 will give you the, so array 2d of 1 will be this list, and so this is like a list, and you can access the first element of the list by writing 0. So up to here it is the accessing array, NumPy array, and after this it is basically accessing the list. So yeah, this notation also can be used, array 2d of 1 0. So this is how flexible Python is or Python libraries are. So 10 will also give you this. Similarly, you can do slicing by using this kind of uh, notation. So we have to move faster. So these things are similar. So you can go through them. So this is the second, this is the third row, and this is again, if you write comma and is to, that means it refers to all the rows. So this is to sign equal to denotes all. um, so it is just like writing two. So this and this will give you the same. If you write some number here, it will give you that particular element that we know. So so fancy indexing. So fancy indexing allows you to select entire rows or columns out of order. So suppose you create a matrix of 10 cross 10 with all zeros, and you store the array 2d dot shape into this variable. That means array 2d dot shape, what does it give? It gives 10 comma 10 as a tuple, but you're writing of 1. That means you're accessing the second element of the tuple. That is, so it will store, so array length will have 10 in it. So if you see what is array length, it will give you 10. So array 2d dot shape will give you 10 comma 10, and of 1 meaning the second element or the index 1 that is containing 10, so it gives 10. So now you are using this for loop, and you are changing the uh, so you're changing the elements in it. So array 2d of I, so this refers to the, what does it refer to? It refers to the entire row. So we have seen already this kind of thing when you assign an entire row or a part of the a slice of the array to a variable, to a number or to a constant. It changes all the elements in it. So when you are assigning a row to I, all the elements in that row will be changed to I. So this is a very powerful tool in NumPy arrays. So once you do this, you can access the non-consecutive rows by using this kind of notation. So we know that in slicing you can give a range like this. Let's say 0 to 2 or 2 to 1, sorry, 1 to 2 or 0 to 2. That means it can only take consecutive rows or columns by using slicing. But here there is another very useful functionality, that you can select the rows which you want to take. So this will give you this row with index 2, 4, 6 and 8. So it is index again, zero based, be careful. So this 2 refers to the third row or index 2. So you just pass a list of the indices of the rows which you want, and this will give you a submatrix containing those rows only. In fact, you can put them in any order. So if you write 6, 4, 2, 7, it gives 6 as a first row, then 4, then 2, then 7. So these are all. So if you want to implement this using list or arrays of the array module, it will be very difficult. You will have to write loops for doing this. But here you can do it just in one statement. So so again, we are seeing selection. So you have an array you have created by using 1 comma 11 arrange here. So you have this array. So now if you write array greater than 4, so this is a relational operation. So we know when you compared two constants, let's say when you compared, let's say a greater than 4 or b greater than 2 or something like that, it returned true or false. Now you are comparing an array uh, using the relational operator. You are saying array greater than 4. So this compares each and every element of the array to 4, and it will return an array corresponding to that. So 1 is not greater than 4, so false, 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 and then 5 is greater than 4, so true. So you can check the entire matrix just in one line, and you get the array containing all the results. So these make your life very easy when you're writing big programs. That is what makes Python libraries very so useful. So basically the result of this is also an array containing the corresponding true or false values. So now one more functionality is, so if you write array of bool array, so this bool array is also an array consisting of true or false. So now if you write array of bool array, it gives you those elements of array for which this input is true. So here it is true for 5 to 10. So it is giving a sub array of 5 to 10. So it is basically a way of selecting only those values uh, for which this condition is true. So instead of writing all these steps, you can further reduce it to only one step, like array of array greater than 2. So it will give you a sub array consisting of only elements which are greater than 2. So you had done here array, so you can write it 4 here to understand the same thing. So you can see that this three steps, array greater than 4 equal to bool array, two steps actually, bool array equals array greater than 4, and array of bool array can be reduced to one step, that is array of array greater than 4. So those elements which are greater than 4 will be chosen and put here. So similarly here. So you can see the how useful the NumPy arrays are. You cannot do this these things very easily by using simple lists or arrays of the array module. So we'll see some more operations of the arrays. So we are creating an array of 0 to 10, and if you write array plus array, so array plus array will add the corresponding elements of the array. So it is like matrix addition or vector addition. So corresponding first element of this will be added to first element of this, and so on. So you can see this was 0 to 9, so array plus array will become 0 to 18 or even numbers. So 0 plus 0, 1 plus 1, 2 plus 2, 3 plus 3, and so on. Array into array will also multiply the corresponding elements. So it's like vector addition and vector multiplication, or dot product, you can say. So that is what we told in the first slide, that arrays are implemented in two fashions, two flavors, vectors and matrices. So one dimensional array will behave like vectors, and two dimensional arrays, or basically nested kind of thing, will behave like matrices. So array minus array, again, it is like vector subtraction. And array by array, uh, it divides the corresponding elements uh, by, like, the first element of this is divided by first element of this. So this is not exactly vector division, um, but but you can understand that it is element wise operation. First element by first element, second element by second element, and so on. So here it is division by 0. That is why it is giving nan. Nan means not a number. So when you are trying to divide by 0, it gives nan, and other things are 1. So by is basically float division. That's why it's giving 1.0. If you write double by, it gives 1 because it is integer division. I hope that everybody remembers that. Here it is 1 by 0, so it is infinite. Here it is 0 by 0, so that is why it was nan there. 0 by 0 was nan, 1 by 0 is infinite. INF means infinite. So you can write array star star 3, array star star 3 meaning each element of this will be raised to the power 3. Star star meaning raised to the power. And if you write array into 3, every element will be multiplied by 3. So some other functions are square root, np.sqrtr, meaning every element of the array will be square root of that will be taken, and exponential meaning e power that element will be given, and np.max. So we had seen this kind of notation before, array.max. You can write it also as np.max of array. So this we had seen in the previous slide, and this is np.max array. So both are same thing. Similarly, you can take the sign of every element of the array by using this kind of notation. Np.sign, np.log. So all the mathematical operations are easily done using NumPy arrays. I hope these operations are clear. And you can see how important these things are to do complex operations. Okay, so we have seen pandas yesterday, we have seen NumPy. We will see two more important libraries in Python tomorrow. Before that, today we will be seeing the uh, theoretical part of machine learning. So what is machine learning? Uh, can anybody say if you have some idea of machine learning?
मशीन लर्निंग प्री प्री एनालाइज डेटा को एनालाइज मतलब उससे फिर डेटा कम उससे कुछ करता है फिर मतलब उससे वो कंपेयर करके फिर वो प्रिडिक्ट करने की कोशिश करता है.
Yeah, so it is something of that sort. So uh, so machine learning is basically we are trying to do something using a machine that we cannot do so easily. So suppose we have some data. Uh, so there are two types of applications of machine learning. We will be seeing that is called supervised machine learning and unsupervised machine learning. So we will be seeing the difference, but a basic idea of machine learning is uh, you want to do something, and human power cannot do it on its own. So we are using machines, we are teaching the machine something, and it will do that operation easily. So suppose we have this data set. So this is the data set of Titanic. So it shows which passenger survived and which passenger did not survive, and these are the details of the passenger. So you have the date information of these five passengers, and some other passenger is given to you, and the details of some other passenger is given to you, and it is not known whether he died or survived. So so how can you predict it? So using seeing this information, in fact it is not only five data. You will have a huge number of entries, which you can analyze. So in general, a human cannot see the data and get the patterns, who what kind of person survived and what kind of persons died. So but you can give this data to a machine learning algorithm, and it will analyze the pattern and will try to predict whether that new person survived or died. So so uh, so that prediction may or may not be true, but it is just a prediction. So that is why it's called a prediction. So 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 it is like estimation, or it's an approximation. Machine learning algorithm uh, is not so obviously it cannot say the exact truth. So unless there is experimental data, so obviously you cannot tell exactly whether the person died or uh, survived. But based on this information, or based on the patterns which you can see who survived and who died, can you predict whether that person survived or died? So that is the question. Why are we using Python for ML? So Python is accepted as a very flexible language and very useful language, especially because of its powerful libraries. So we have already seen two libraries, NumPy and Pandas. You'll be seeing Matplotlib and Cmon as well. So these are very important. They provide useful functionalities. All the basic code is written. So we just have to use functions, and our work will be done very easily. So Matplotlib and Cmon are basically used for data analysis. So it will give you different plots using which you can analyze the data very easily. Visualization of data becomes very easy. And SciPy is used for, uh, it contains very useful functions for doing complex scientific operations very easily. And scikit-learn is the most important library for machine learning, that makes machine learning a very simple task. So you will see how complex procedure is there for machine learning, but using scikit-learn, you can do the entire procedure in just few lines of code without even knowing what is happening in the background. So there are predefined functions in scikit-learn that will do all the job for you. You just have to write that function You just have to call the function. So as I told, there are two paradigms of machine learning. One is called supervised learning and second is unsupervised learning. So supervised learning is basically uh, you train them. So basically you want to find the uh, some output value. You want to find the output value depending upon the known data. So for example, the above example which we saw is an example of supervised learning. Here I know some data is given to me, and for these people I know whether they survived or not. 0 means died and 1 means survived. So I know the information for these people, and I have some new person, and I want to know whether he survived or not. So I have some target value. So this survived is my target value, and these are the other parameters based on which uh, I will try to find a pattern and predict whether this person died or survived. So this is an example of supervised learning. So I have some target value here, uh, which depends on other features. So this kind of a problem is called a supervised learning, machine learning problem. So some practical scenarios will be image and speech recognition, recommendation systems, and fraud detection. Recommendation system, I think you can easily understand, because so how does YouTube or Netflix give you recommendation of videos? So it uh, depending upon your history, like what kind of videos you have seen or liked. So that are the features. So it is using those features to predict which kind of video you might like. So there is some target, right? The target is whether you will like certain video or not. So there is a target, and it is dependent on some features. So your history and which kind of videos you have seen, liked, commented, or spent more time on, and so on. So there are two techniques in supervised learning, that is classification and regression. Classification means you want to it is a categorical variable. So above example is a example of classification, because you want to classify whether the person died or survived. So there are only two options, 0 or 1. But regression means you want to find a value which is a continuous variable. Suppose you want to find the so you have the data of houses, the rate of houses, the cost of houses in some place, and you want to predict the price of some new house constructed, which is constructed. So there are different parameters like the size of the house, number of floors, number of bedrooms, and the material used, and so on. So there can be different features upon which the price of the house is dependent. So this is an example of supervised learning, and it is a regression type of technique, because the price of a house is a continuous variable. It need not be one value or the other. So it can be any value uh, which is positive, right? So it is a continuous variable, and classification means it is a discrete variable. You have only few options. You have discrete options. Instead of few, you can say discrete options. And unsupervised learning is um, basically you don't have your target value. That means uh, you can see that unsupervised learning is a paradigm in machine learning where algorithm learns patterns exclusively from unlabeled data. That means you don't have, there is no predetermined target. In other words, there are no historical answers that we can learn like we would ordinarily do with supervised machine learning. We let it discover patterns and groupings on its own. So here you don't know what exactly to find. You want to find some patterns. So if you see the applications, then you'll understand. So natural language processing, image and video analysis, anomaly detection, and customer segmentation. So you can take the example of customer segmentation. So suppose in a bank, you have the data of different customers and their transactions, or their the amount of loan they have taken and how loyal they have been. So you can run an unsupervised learning algorithm on your data, to classify the customers as loyal and non-loyal, so depending upon how they dealt with their loans and credit, etc. So here you don't have you don't have a specific target. Your system itself will you give patterns based on your data. No, ChatGPT is not it is not exactly a machine learning thing. It is generating answers, right? So it is AI. So AI is a broader category, and ML, machine learning, is a branch of AI, which is dealing with statistics or this kind of uh, predictions. So machine learning, for machine learning, you have a data set, and you want to get something out of it uh, by analyzing the data, by using patterns in it. ChatGPT is a different thing. It is AI. It does not fall under the category of ML. Of course, ML is used to teach it. Suppose you want to generate an image of a cat, then obviously yeah, so many images of cats were fed into ChatGPT, and it learned what is a cat from there. But when it is generating a cat, it is obviously AI. So it is so ML is a subset of AI, is a branch of AI. So obviously, so wherever there is AI, there is ML, but wherever there is ML, there need not be AI. So you can see the techniques used in unsupervised learning, like clustering, market basket analysis, dimension reduction. Clustering, so so suppose in a big shopping mall, you have the data of customers, what they bought. You have the data of customers and the items they bought. So you can run an unsupervised learning model to determine what kind of customers bought what items. So there is no uh, uh, predetermined value, like for this customer tell me something. No, you're not asking that kind of a question. You're just asking your uh, model to find patterns in the data, which gives you what kind of customers bought what kind of items. And market basket analysis is also similar thing. So if uh, so so which item was bought along with another item. So you can see in Amazon, when you book something, it will also show you uh, people who bought this also bought. So you can see that, right? So those kind of things. So people who buy one item are also more likely to buy another item which is related. So that is market basket analysis. So it analyzes which items are bought together usually. So this is just a grave idea of what is unsupervised learning. So this is more complex than supervised learning, because in supervised learning you just have to train your model depending upon the given data and get the output for a given expected variable or feature. So there are two types of data that we'll be talking about, that is numerical data and categorical data. Numerical data means, obviously by the name it suggests, it takes numerical values. And categorical variable means a non-numeric value, you can say, which is usually discrete. So numerical value are usually continuous, categorical variable are usually discrete. So now we have seen supervised learning and unsupervised learning. We are not going to deal with unsupervised learning because it is more complex than supervised. So we are going to start with supervised. We are going to do only supervised, and in supervised we are going to do regression. So I hope everybody is clear with what is supervised learning. So our data is given and we need to predict something. And in regression, the variable to be predicted is a continuous variable. So in regression, two types of variables are involved. One is a dependent variable and independent variable. So dependent variable is a variable whose value you want to predict. And independent variable can be more than one or more, but dependent variable is only one. Independent variables are the variables on which this dependent variable depends. So you want to predict the dependent variable based on the values of independent variables. So a dependent variable is usually called y, and independent variables are usually called x. Note that in regression, y must be continuous variable. So if it is a discrete variable, then it becomes classification problem. It is not a regression problem. So regression itself means y is a continuous variable, and x may or may not be continuous variable. It may be categorical as well. So there are two types of regression models: simple regression and multiple regression. Simple regression meaning there is only one independent variable. Multiple regression means there is more than one independent variable. So here y is a function of 1x, here y is a function of x, where x is not just one value, it is a set of features. It is like a vector, or you can say it is depending on x1, x2, and so on. And each of this regression can be linear or non-linear. Linear means, as the word suggests, it is a linear relationship, and non-linear is which is not linear. So these terms are self-explanatory. So we are going to see simple linear regression. So we are going to see how simple linear regression works. Um, Obviously, this is not going to be the way which which we are going to implement in the code. In the code, we are just going to use scikit-learn functions. But the background of scikit-learn function will be this. So simple linear regression meaning, so we know what is simple regression. There is only one independent variable and obviously one dependent variable, and it is linear. So we are giving a linear approximation to our data set. That means we are trying to find a linear relationship between y and x, uh, that best suits our data. So when you plot the data, suppose if it is like this, you want to find the best fit line uh, to describe your data. I hope it is clear. It is making sense. Is everybody following?
Yes, bro.
And you want to find the best fit line. So so uh, uh, so how do you quantify a best fit line? So when do you call a line as best fit? So we will quantify it by using the error. So residual error is basically yi minus yi cap. So yi is the actual value, which is the blue points, which are the actual values, experimental values, which are present in our data set. Can you hear me? Sorry for the disturbance.
Yes, bro.
Okay. So uh, these blue points are basically yi, and the corresponding point on the line is yi cap. So yi cap is a predicted value, or basically the value which you obtain by the line, and yi is the actual value. So this is called as a residual error. I meaning the data points, wherever the data points are present here. So this is xi, and the corresponding value on the line is yi cap, and the blue point is yi. So that is called as a residual error for a given point, and the total error. How do you quantify the total error? That is quantified by mean squared error by this formula: sigma yi minus y cap square divided by n, mean of the square of the residual error for each I. Okay. So basically, what does a linear regression model do? A linear regression model will just find a line such that this is minimum. So that is what it is doing. So uh, uh, so that is just the function. That is all what it is doing. So it is finding a line of beta naught plus beta 1 x such that MSC is minimized, and you can find such a beta naught and beta 1 by appropriate mathematics, differentiation, and other things, and you will end up getting beta naught is equal to y bar minus beta 1 x bar, where beta 1 is equal to this. So sigma xi minus x bar into yi minus y bar divided by sigma xi minus x bar whole square. So x bar and y bar are the average value of x and y. So average x bar is the average value of x, and y bar is the average value of actual y. That means these are not the predicted values. These are the values in the data set. So this xi and yi which we are talking about is the value in the data set, not the predicted value. When I use cap, only that is the predicted value. Yi cap is the predicted value. When I'm not using cap, it is not the predicted value. It is the element in the data set. So this is how a linear regression model works. Simple linear regression model works. So this is the math or the background of the simple linear regression model. So we are not going to write the code for finding this mean square error and then minimizing it using this formula and so on. We are just going to use a function of scikit-learn which does this all calculation in the background. And once we get this beta naught and beta 1, we have the line and we can get the predicted value of y for any value of x. So this is basically our prediction. So this is how, so using the xi and yi, the machine learning algorithm found out beta naught and beta 1. That means it has learned from the dataset. So learning from the dataset is basically this. From xi and yi, it has learned something and got beta naught and beta 1. And using beta naught and beta 1, it is able to predict values for new x. Okay, so how do we evaluate the regression model? So once you have given the got the regression model, how do you evaluate it? Evaluate means how accurately it is giving you the results. So we know that as we mentioned before, it is just a prediction. It need not be exactly correct. So how close is it to the exact situation? So we can quantify the evaluation by various errors, various quantities. So MAE is basically the mean absolute error, whose formula is basically mean of the absolute error, and mean square error is square. So this is a better option than mean absolute error because because why? Because larger errors will be more magnified here. So larger errors will be clearly seen. There is a large error somewhere, and this will be clearly seen in this one here. But here it may not be seen so brightly because large errors, square of a large value is large, and square of a small value is even smaller if it is less than one, right? So 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 when there's a large value, it will get dominated by square when it is squared. So large errors will be visible in this case. And then a more popular one is root mean square error. So everybody might be familiar with root mean square. So root mean square is basically square root of this error, and this is even more popular because this has the same units as yi. So this has, so if yi has unit some, let's say meter or something, here it will be meter square, but here it is again meter, root of the mean squared error. So this is a better quantification of the error. Can you please upload yesterday's session on Google Classroom? The yesterday's session was unfortunately not recorded, so that cannot be done. Tomorrow we are going to revise pandas. You can go through the pandas this notebook which is uploaded before the class so that you can understand it. We are going to revise it tomorrow. Don't worry. This is so RAE is again relative absolute error, and this is relative squared error. So this is the error with respect to the actual value and the predicted value, and this is the total absolute error, yj minus y bar. So this is when you divide, it's a relative, and this does not have any units. So these are all errors. Different types of errors are used to measure the efficiency or the accuracy of the regression model, depending upon the situation, depending upon the application. It depends on various factors which error is used. So all these are errors, or they're also called as loss functions. Loss functions meaning you because you want to reduce these errors to make your model better. So the loss functions must be reduced to make the model better. But there is one more popular metric, R square, which is 1 minus RSC. 1 minus RSC is, this is RSC. 1 minus RSC is called as R square. And this R square is also a popular metric. So when somebody says what is, a model with higher R square means a better model. So this is also a popular metric that is as popular as RMSE, root mean square error. So this is just to be known. So people use R square to describe a model. So you should know what is R square is. So here errors should be minimized to make a better model, or basically R square must be increased to get a better model. So this is how we quantify evaluation. But how do we evaluate? But how exactly do we evaluate? So for evaluation, we have two techniques: train and test on the same dataset, and train test split. So train and test on the same dataset means you train your model by using the dataset, and you test the model based on a portion of the same dataset. Suppose you train the model based on this dataset, these 5 elements. You have trained your model and you are checking the output. That means you are testing the output for these two last elements. These two last rows were used for training as well, and you are testing for this only, testing for these last two elements. So it may or may not give the exact answer, because as you know, you can see the simple linear regression model. We So all, see, you can see that the line need not pass through all elements. It is just the best fit line. The best fit line need not pass through all elements. Obviously, if they are not on a straight line, it cannot pass through all elements. So even the best fit line may be deviating from the blue points, some blue points. So it may not give the same answer again. But you can suppose you adopt this kind of a method to test your model. You are training on the entire dataset and you are testing on some subset of the same dataset. So what do you expect for that kind of a evaluation method? So is that a good evaluation method? No, because this yields high training accuracy and low out of sample accuracy. So what is training accuracy? Training accuracy is a percentage of correct predictions when tested using training data. Meaning, so you have trained the model using some training data, and you are testing using that only, using a subset of that only. And whatever the percentage of correct predictions, correct in the sense not exact, you can define what correct you want. So you can define correct as within a range of 0.2 or something like that, depending upon what exactly you are predicting, and how much you can consider as correct. So that percentage is called as training accuracy. And out of sample accuracy is you train on some data and you test with new data which was not used for training. So when you test with new data, that is called as out of sample accuracy. The percentage of correct predictions in that is called as out of sample accuracy. So do you want higher training accuracy or out of sample accuracy? Anyone? Speak up. Yes, out of sample accuracy. Why not training?
Out of something.
Yeah. So obviously training accuracy should also be high, but the more important thing is out of sample accuracy. So if you have good out of sample accuracy and somewhat lesser training accuracy, it is better, because if you simply want higher training accuracy, it will be just like an overfit. That is called an overfit. Overfit means you are just training your model to give correct answers to the data which you have trained. So if you're overly adjusting your model to give correct answers for this, it may not give correct answer for new data. So you want correct answer for new data, because that was your aim. So if it is giving good results for new data, you need not adjust it very um, uh, very harshly in this to the present data. So very high training accuracy is not good, because it will indicate an overfit. So this, when you train and test on the same data, it is not a good method of measuring the accuracy um, of your model, because it will be most likely an overfit. Because you will try to improve the accuracy, and when you're trying to improve the accuracy by this method, you're basically tuning your model to give correct answer for the present data set only. So that is not what was actually expected of the model. That will become an overfit, which is not required. So we use another method that is called train test split. So in train test split, you split the given data set into training and testing parts. So suppose you have this data set, you will split into two parts. Let's say two parts for testing and two rows for testing and three rows for training. So you will not use so less data. You will obviously use very large data, hundreds and thousands or much or many more. But just for an example here, suppose you are using two rows for testing and three rows for training. So you train on these three data and you test the output for these two data. So this is a better method, but this is a better method to determine the accuracy. But the problem is that uh, the accuracy depends on which part of the dataset was used for training and which part was used for testing. So it depends on, um, so suppose you use these three rows for training and these two for testing, it might give different accuracy. If you use these three rows for testing and these two rows for training, it might give different accuracy and so on. So that is one problem. So that is solved by using k-fold cross validation. K-fold cross validation means, as I told you, you will so let's say k is 4, then you will be doing 4 times. That means, let's say first I'm doing these two things as the testing and these three as training. Later these two as testing and these three as training. Later these two as testing and these three as training. Later these two as testing and these three as training. So I will do it 4 times. I will calculate the accuracy for all of them and take the average. So that will be my overall accuracy, which describes my model more better, in a more better way. But anyways, determining accuracy is not of that much concern for us. Our main concern is not to make it an overfit and make it a better model. So we will be simply splitting using train and test in our next example tomorrow. And we'll be using this method to evaluate our model by splitting the data set into train and test. One more additional point is that after testing it using the second half, you can train it with the entire data, so that you don't have, so that when you test for out of sample, when you use it in a real application where you have a new data, you can you can have better results because you have used the entire available data set. So I hope the basic idea of machine learning and regression model is clear. Tomorrow we'll be seeing the code of a simple regression model, a simple linear regression model, not exactly simple. We'll be seeing a multiple linear regression model code, and then we'll conclude it. Before that, you will be seeing Seaborn and Matplotlib. So I hope it is clear. Ansprabhu, do you want to add anything?
I have uploaded the pandas or tutorial on the Flows classroom, so you can access that. And if you have any doubts, you can ask. Okay. Unfortunately, the video I forgot to record the. Uh, Sorry for that, but if you have any doubts, you can ask. It was a clear, मतलब simple था वो, understand हो जाएगा. और मैं मैट प्लॉट लिप का भी आज ही अपलोड कर दूंगा, और ताकि तुम लोग कल देख लेना. हम लोग कल कल दो लाइब्रेरी भी कवर करना है, और ये मशीनिंग का भी है. कल लंबा अक्सर से हो सकता है, तो इसलिए तो हम देख के आना. मैं मैट प्लॉट लिप और सीबॉन का अपलोड कर दूंगा अभी. ठीक है, तो वो देख लेना.
See, these libraries are basically consisting of functions. You just have to know how functions work. So, and in pandas, you have the data frame, and in NumPy, you have arrays. So some data structures might be present like this, but mostly you will have to just know different functions. You don't have to remember everything, but just knowing, so these kind of functions are there. I can do these things with the library. So that kind of understanding is enough.
मतलब वही है,
Are
जैसे
there
पांडा से भी कल वही था कि फंक्शन से हम वो डिफाइन कर लेते हैं, फिर यूज कर लेते हैं. सबको रटना नहीं होता, मतलब बस सीखना होता है कि कैसे यूज करना है, काम के अनुसार कैसे अप्लाई करना, बस वो चीज है. तो मैंने कल डिटेल में समझाया तो मैं एक्सटेंड हो गया था. लेकिन कल और मैं इतना डिटेल नहीं करूंगा, क्योंकि वो बस हमें यूज करना आना चाहिए बस. ठीक है. somebody was saying something, I think कोई कुछ बोल रहा था.
I think it was me only. Does
Yes,
anybody
sir.
have any doubt?
Okay.
If there is no doubt, we can end the session.
बहुत लेट हो गया तो we can end कर सकते हो, डाउट हो तो पूछ लो जल्दी।
Very few
Ask
people have
mathematical chapter।
very few people have submitted assignment 2, so you have today also to submit. So if you are really interested in learning or doing something, you can do it. If you like, it is not very difficult assignment. So even if you're not getting, you can contact us and submit it by today, because we will be releasing the programming contest tomorrow, like tonight. So it is good if you practice. Apart from that, we can't say anything. It is your wish. Okay. So we'll end the session. Hare Krishna.
दूसरा भी